Hi, my name is Sam O'Brien, and I am presenting the lock design pattern. The lock pattern is intended to act like a physical lock on a door. It can be locked or unlocked and given specific conditions in order to give or deny access. The lock pattern prevents unauthorized access to an object, such as a database, a file, something in a game, and many other things that would negatively be impacted by unchecked access. There are many levels to the lock pattern. The mandatory lock only permits one user at a time to have write access. The limitation lock gives a hierarchy of access so that multiple users can access at one time, but not overwrite each other. The spin lock makes each user wait its turn and allows access once the user before logs out. Some examples of where this can be used are databases so that no user can overwrite the other, a bank account where, for example, without the lock pattern, a user could log in at multiple locations and withdraw all the money at the same time and get more than he is owed, or in a login system, simply not to allow someone to log in without proper credentials. The motivation behind the lock pattern has many different uses. It can give users different access privileges, for example, reading and writing privileges versus read-only privileges. It can prevent some users from seeing certain data, whereas others can see all of the data. It can limit the program so that only one user can access an object at once, so no data is overwritten and therefore nothing is lost. And it can create a hierarchy of users so that it is not limited to just one user at a time having access. The structure of the lock pattern has many different implementations which are dependent upon the needs of the program. For example, where only one user can access, only one user is allowed to log in at a time. This is to prevent overwriting. Another structure would be where different access levels are allowed, where one user can read and another user can write to data. This still prevents any data being overwritten, but multiple users can have access at the same time. The third structure is where users take turns and they all have the same or different levels of access. The lock pattern sequence diagram is where the user logs on, the database locks itself, the lock pattern checks the credentials, and if they are correct, the database locks itself to all other users and allows this user access. Here's an example of a database using the lock pattern. First, we will try to access the database, and we can see that none of the fields are available for us to use. So first, we need to log in as the manager, and we can see that now we were able to access these fields and type. So we will add a product, we will add a shirt, for $6, given the product number 1111. If we click insert, we will get a pop-up that the record was successfully inserted, and we can see in the database that shirt with product 1111 has been inserted. Now we will try to log in as a cashier, and we can see that the database has locked itself to any other user because one user is already logged in. So before we can log in as cashier, we must log out as manager, and the database is unlocked, and then we can log back in as the cashier. So now we're able to use the fields again, And this time we will try deleting the shirt record since it is just a duplicate of product number 2222. So in product number, we type in 1111 and we delete it. And we get a pop-up that tells us that it was deleted successfully. And we check and we see that product number 1111 is not in there. So we come over here and try again. We see that we still cannot log in as manager because we are logged in as cashier, so the database is still locked. And that is the purpose of the lock feature. Although there's many benefits to the lock pattern, it does have consequences. For example, if the process that currently has access to the object is waiting on information, it would unnecessarily be holding up all other users and processes. If the application is something that many users need, there could be times where there are many people waiting on just one user. If one user forgets to log out, the application could be locked to everyone else for extended periods of time, which could cause many issues for the users. If the program is first come, first serve, you can easily run into situations where one person logs on with a very long and tedious task, but another user must wait the entire time even though they have a very simple and quick task. Some solutions for these issues are to place a time limit on how long a user can have access until it's automatically logged out. This will not solve the issue that users must wait, but it diminishes the time where users must wait and will prevent deadlock. Another solution would be giving different access levels to different users, and that will help keep users and processes from waiting because they do not necessarily need to wait for the user or the process before to access the object. This would be helpful if the first user to reach the program needs write access and it needs to add things to the database, and the second process that comes just needs read access. It just needs to see what is in the database. It would not need to wait for the first user to be done. It would be able to read into the database. So that is the basics on the lock pattern, all of its benefits and issues.